trophies out there, I guess. Well, I'm super happy to be here. My name's Toru Hasegawa, co-founder of Morpholio. We are a group of architects making software for architects. So in other words, I'm making software for myself to use daily. So I do still practice architecture when I can, but a lot of my time has been taking over to make the software. But at heart, I am a designer and architect really interested in the workflow of designing. So a lot of the topics, and Charles said optimistic view of future of technology, hopefully I could sway you guys also to that side if you've been on the dark side. So let's go. First of all, my topic is a lot going to be around human-computer interface. So in other words, the evolution of how we relate to the computer is kind of an important piece of information to our talk. And secondly, at Morpholio, we truly think how the iPhone doesn't come with a manual, that by design, you can have tools that are designed well to not have to have so much overhead to learn as well. So, you know, what is technology? So my topic is about fuzzy tech. So just to define a few words is always good for a presentation. Technology, just by the history of it, Industrial Revolution allowed us to dig holes miles down, wide, tall, make buildings tall as, a kilometer. The computer is kind of an interesting point in that technological advancement, is that it allowed us to compute a lot of things. So, and some people say it's personal computer expands the mind, right? So that was Steve Jobs' comment about the bicycle is like the computer of the mind, vice versa. So that also comes into the internet age where we all have a voice, we can all access information, so that also amplified our ability to access, and mobility devices also is kind of one point where now we can go anywhere, know where our locations are. It's really amplifying our mobility. So these are things that are the nature of technology. The interesting thing of where it's going, and this is partially why I have high hopes, is computers becoming more human, or in other ways, more humane. So if you look at the first one, the ENIAC, now as big as this room, you had to put these plugs and maybe it worked. You put some punch cards, maybe it ran the computer, right, or your program. That was so abstract. There were so much layers of abstraction. First to set up your machine, then set up your program, then set up if the electricity is coming right, and then finally you had the outcome. But now we say, hey Siri, we flick our fingers on a phone. That abstraction has reduced so little that it is becoming thought to interface to thought is becoming very, very close, if not real time. And that's an important fact because a lot of that intuition of designers really rely on that moment of feedback. Now, just to kind of point out, the interface of the mouse and keyboards are great ways to precisely input information. So a keystroke of A, of course the machine wants to know it's an A, or a click to 2 points, you get the perfect line. But actually when we think, it's not that straightforward, right? We're kind of scribbling, and maybe no one scribbles in this room anymore. I still scribble, but that's where the ideations happen. Now, this is not from nostalgia. This is not from, really going back to an interface, antiquated interface. Actually, that is the right pace to an extent. So sorry, Siri's telling me something. Siri just listening into my lecture. So when you have linear interface, and this is interesting to see James' presentation about the UI of that places where it was touched a lot. With the linear way we think with mouses, you think, you decide, and then you press, right, a gesture. Just think about that. That process versus as you're doing something, you're thinking and making decisions. So that's the other redirectional interface, which is gesture happens in parallel with thought. That interface difference is actually very, very critical to point out. And not only is it kind of a point to define some, interface, let's say, the best interface. I'm not talking about the best interface. The right interface for designing or the thinking or discovery relies on that. There's this very interesting research done in brain science, and I've tapped into that a little bit in my career as well. The Necker cube, you guys, we can do this experiment right now. So if you look at that cube, everyone will see one of that corner, right? Let's say that second from top corner to be in front. But you could also see that cube to think that second from the bottom corner to be front, right? If I made you guys stare at this for over 10 seconds, every 3 seconds, your view of that cube corner will flip. We don't have to do it for 10 seconds, but try it. And what happens is you don't have control over that. This is done in neuroscience. They tested. Of course, it's not a perfect 3 seconds, but that corner will flip-flop every 3 seconds. Like, you can't control that. That's a biological metric of 3 seconds. There's a 30 millisecond rule, which is also interesting, called sensorial distance. So when I tap on 2 of your shoulders, if it's less than 30 milliseconds in time, you cannot detect the difference. In other words, if it's beyond 30 milliseconds, you know I touched you left, right. But if beyond that, as humans, we can't comprehend time frames of 30 milliseconds. So it's this like blank abstract universe that exists in our head. And the 300 millisecond is also done a lot in neuroscience about event-related potential. So when I present you something like a disturbing image or some flashy image or whatever it is, it takes 30 seconds for that image to go to your visual cortex and you'll have a thought. So in other words, your thoughts, or other words, the 3-second rule, is that you need a 3-second buffer of time to even have a thought. So as amazing as these computational tools are, it's amazing. It generates the millions of options. Great. It's a great selling point. But we can't process a million thoughts. So then it becomes this issue of how do we make the right rules to find the right ones. That's a great paradigm. But when we're dealing with our own heads or the way we interact with these things, these time frames are actually very critical. So at Morpholio, we do kind of take this time scale quite significantly directly. So one example here is one of our drawings. So to us, drawing as an interface of thought, like real-time decision thinking, processing, ideation is true. So sorry for the glitches. This is PowerPoint. We can sue Microsoft. But you will see that as you're drawing, you saw the area just update you in front of your eyes. So this kind of direct input feedback at that pace is actually the right pace. If it just told you instantaneously or you swap the pace to do something else, you just don't have that ability in your brain to have that cache remain to address a thought. So some of these thinking, also the tools that we're looking at are artificial intelligence, has been talked today, also AR and API. So I'll go through them and kind of discuss why these topics are essential and how it's helping as designers. So AI is such a big buzzword right now, but when you break it down and the history of it is data mining, sometimes it's just pattern recognition. I mean, it's not a scary, future of AIs taking over the world, right? It's pattern recognition. We do this every day. What this machine learning stuff is the latest technique. It's really amazing, to be honest. I mean, that's why we get better spam filters, Amazon recommendation. They're not life-threatening things. But if we could use it to our advantage, is quite interesting. And this is super bare bones. Sorry for experts out there, but just to give what it's doing is a little bit of a paradigm shift. Before, we were monkeying around as programmers, figuring out input, make a program, and we had an output. That's a traditional way of programming. Machine learning kind of takes it upside down. You input, output, and a program is spit out. We don't know, well, expert of experts will know what's happening, but that program is what comes out and has quite a very sophisticated way to address what your problem was. In other words, we could automate anything, but if you can't describe or have the input-output to define that, there's still no, overlord AI taking over yet. But that said, what's interesting here, and this is where it's the fuzzy tech, is that you can put in anything. This is very different. Before in a traditional software, if you put a bad input, it halted. It was a bad input. You couldn't do anything. That was it. It's very useless as a tool. But what machine learning tools are doing for us is almost the opposite, and forgive me for this glitchy video again, is that you can almost put anything. Now, guarantee that it's not a good result, but it will process it. But this fuzziness is actually very critical because fuzziness equals discovery. So input, punch it in the computer, tells you, go screw yourself. We can't process it. That's not a really good discovery tool. But if you could be really in this kind of hazy way to interact with computer, it actually will help you discover, and it will allow you to discover new ideas. So this is kind of a prototype we still have going. It's called the shape finder. So rather than saying, like, give me just a red chair, which we do, we could find a shape we're interested and just put it into a Morpholio board, and you'll find similar products that are in a similar shape. So this is using machine learning. So maybe your client does like something that looks like a starfish. Just put that image in there, and we'll find furnitures that are related to that. So again, that fuzziness is so vital, like as designers. Like this is a little different from making actual parts at the end. We're trying to discover new ideas, and how we want to interact wants to be at that level that is still fuzzy. This is another prototype we're doing with semantic segmentation, and this is what all machine learning and autonomous driving do, right? They take an image of the world, they want to know that's a human, that's a car, that's a road, that's a sidewalk. But if you could took this to with your client in the living room, we just sway our device, and it'll say, oh, there are 3 chairs and 2 tables, and here's a certain current pattern of X. We can start understanding that. So this was just a way to figure out our next steps in how we're interacting, not just with our design process, but the environment we're surrounding. And that's something that will take us to our AR scheme stuff at Morpholio. Again, most of you probably already know this. There's the real world, unless this is simulated world that Wolfram says it is, or the virtual, which we are probably plugged in most of the time, right? We look at our phone. A lot of the tools that we've been surrounded has been heavily in the augmented virtuality, right? This is examples like Google Maps. Like you have the map that shows where you are on it. So it's in the virtual that is augmented with information. Or weather maps. You see a weather map on your screen, and you see real-time data coming in. The augmented reality side, it came big with Pokemon Go. It's like you put the other way around. It's been less so developed. Or in the context of tools, just because the UI haven't existed. But Apple has obviously kind of given us a pretty powerful tool to do this. So this is one of our perspective finders where we're just capturing our environment. Again, we're roughing it in, fuzzy input, but extracting the surfaces, laying a grid that we can then draw on top of and go through our ideas. Another one is our AR sketchwalk. So this is, again, you have a floor plan that you want to test out in your environment. You could just tap onto your device. Again, we don't move like this. We put it into our scene. It's a true scale floor plan, so you can tell your client, hey, this is how far it's going to be from the kitchen to your dining room. This is called kinesthetic understanding. There's educators that don't believe in there's better learning, whatever. But when I say, hey, this is about how far it's going to be, you know it's going to be good or bad. A client will look at a floor plan and say, hey, this is the perfect 24.5-inch distance. It's so abstract as the information, it doesn't do anything. So kinesthetic learning is powered by these AR tools, is a better way to make right decisions. The API side of things is just a comment or point for us about tools and software have been traditionally in file format, right? You have your AutoCAD file, you have your Revit file, you have your Rhino file. It's the way it's been done, but with the current web interface, WeWork has presented a big infrastructure, how they could deal with information is mainly because there's APIs. So you could access information, digest information. It's more flexible. So this is part of our board app that we do connect with Pinterest to bring in information. So it's not our domain, but it is a way to bring in more collections of images and so forth. Another collaboration we had with Shaper 3D is just this bridging of 3D model files. So rather than, again, the whole process of export, import file formats, this is just a matter of drag and drop. So this is a pretty amazing solid modeling platform that you could easily drag and drop into trays. Let me just jump to that point. So this is the drag and drop. Now, it's not just to show off that it's as simple as that, but it is tying back to the concept of no disruption in the thought flow. So there's no disruption when you just say, oh, here's my model, I want to bring it over here. Before, you would have to save it out somewhere, export it, then digest it, bring it back in. At that point, you do lose what you were even thinking, right? Again, remember that 3-second rule. You can't break that rule. You can try to stick a memory to what you're doing, but it's actually very hard to retain it. Again, I'm probably running a little long. Good. Again, technology is an amplifier. It is still this kind of form of what you put in, what comes out. So garbage in, garbage out. So whatever thoughts that go into is really vital for us. So that is still coming to that. Even though we can automate things, whatever you're putting in is eventually what's the core of what's happening. So just as a summary points, fuzziness equals discovery. So a lot of the technology that we're seeing and developing are towards this direction, which is great for us because that helps us or even amplify our ways to discover things. So AI, ML, all this stuff is semantic interaction. So it's not just, it's a data point, like a binary on-off, red, blue, X. It could feel like a chair that looks like a wide and et cetera. To understand even more is what these computers are being able to do. And AR is the biggest probably component of kinesthetic understanding, has been very far from architects because we can't make the real thing in real life quickly, right? It would be immense, but there are these portals now to say, okay, let's just test what this office layout looks like or feels like and make a call. So design, eventually, at least for my take, is discovery and decisions. So all these tools that are revolving around fuzziness tech is getting closer to how we would want tech to respond to us. Thank you.